Chapter 3, Section 2, we learned this formula. The derivative with respect to x of the natural log of something, I'll call it u, is 1 over u, 1 over this something, times the derivative of that thing. So here's one more derivative formula to learn, along with all the other ones you have. On page 334, exercise 62, y equals the natural log of something, 7x squared plus 5x plus 2. It says differentiate, that means find the derivative of y with respect to x. It's simply, very simple, it's 1 over this thing in the parentheses times the derivative of the thing in the parentheses. That's all. Anytime we have the natural log of anything, the derivative is always 1 over the thing in the parentheses times the derivative of the thing in the parentheses. The derivative of 7x squared plus 5x is 14x plus 5. So there's your answer, which also could be written like this. dy dx equals 14x plus 5 over 7x squared plus 5x plus 2. That's just multiplying the numerator 1 times this numerator over this denominator times the 1 that you can't see there. That's all. In chapter 3, section 3, we talk about something called differential equations. A differential equation is any equation that has a derivative. Here's an example. This is an equation because we see the equal sign. The equation has a derivative, dy dx, so this is a differential equation. Any differential equation that has this form has the solution. This is the solution. Y equals c e to the kx. Now this is going to take a lot of getting used to, so you'll see an example, but you're going to want to practice a lot. The solution to a differential equation means, or to solve a differential equation means to get this variable all by itself on one side of the equal sign and not at all on the other side. But the variable that's down here, in this case x, will be on the other side of the equal sign. So y all by itself equals this. In the given differential equation, this would be given, k will be some constant. It should probably be given. In the solution, that k will be the same constant that's in the given, that k in the exponent. And the c will also be a constant, but you'll have to find it. And then we'll do an example to demonstrate what we're talking about. On page 347, exercise 8 says, Pizzazz Incorporated is selling franchises for pizza shops. Oh, Pizzazz. Selling pizza shops throughout the country. The marketing manager estimates that the number of franchises, N, will increase at the rate of 10% per year, which is symbolized like this. The rate of change of the number of franchises with respect to T will equal 0.10, that's the 10% of the number of franchises. So this actually is given. It was given in words in the paragraph, and these are the symbols This is the symbolic way to say those words. And now we're going to take this given information and find the function that satisfies this equation. Since n is in the numerator, that means we're going to find n. And it's going to be some function of the letter that's down here in the denominator. So this is the goal. So, using what's here, that n, which is the numerator's letter, equals c, some constant we have defined, times e is a special number, 2.7 approximately, raised to the k is the number that's next to the n over here. So it's e raised to the 0.10. We said x in the notes up here because an x is down in the denominator. But in this problem, we're going to say p next to that. Like I said, this takes a lot of getting used to. So we'll start with this, which is really coming from our notes up here and the given differential equation in this exercise. Part A also says, besides find the function that satisfies this equation, it says assume that the number of franchises at t equals 0 is 50. The number of franchises is 50 when t is 0. So that's telling me to replace this t with 0 and the number of franchises with 50. From this we get 50 equals c times e to the 0, because 0.10 times 0 is 0. Any number like e to the 0 power is 1. Any number raised to the 0 power is 1. So we determine this 50 equals c. C times 1 is c. So all we do is take this 50 and put it in that spot. We're going to say our answer to part A coming from this is n equals 50 that we just found times e to the 0.10t. That's the number of franchises. That we say that this equation, this is the solution to the given differential equation. Part B, how many franchises will there be in 20 years? The number of franchises in 20 years will be 50 times e to the 0.10 times 20. The question is asking how many franchises will there be in 20 years? P is time in years. My calculator says that 50 times e raised to the 0.10 times 20 is about 369. We have to make this a whole number because it's the number of pizza franchises or stores. It would not make sense to have a decimal. Right, that's part B. Part C, in what period of time will the initial number of 50 franchises double? So here's the formula for the number of franchises. If the number of franchises doubles, that means the number of franchises will be 100 equals 50. That's how many originally. E to the 0.10t. So we're taking this formula and replacing n, that's number of franchises, with 100 because we're trying to find the time. We want to find the time it takes for the 50 franchises to double. We solve this equation by dividing both sides by 50. So the 100 became a 2, and this side, the 50, canceled. Divided both sides by 50. Now we take the natural log of both sides. We say the natural log of the left side has to equal the natural log of the right side. And the reason we use natural logs is because a property of logs is the exponent whatever this exponent is can be written down here in front of the log. When we have the log of something to an exponent, we can drop the exponent down to the front of the log. So we have the natural log of 2 equals 0.10 times t, because, as we mentioned in an earlier video, the natural log of e right here is 1. Now we're going to divide both sides by 0.10. The natural log of 2 divided by 0.10 equals t. So we're going from here to here, dividing both sides by 0.10. On calculator, I see the natural log of 2 divided by 0.10 is about 6.931447. And this does not have to be a whole number because this is t. T stands for time, and time is in years. So I'm going to say it takes about 6.9 years. It would take about 6.9 years for the 50 franchises that were there initially to double. So 6.9 years, or very close to 7 years.